Hello friends, plastics are majorly used as packaging material in various food products. Now in this module we will learn about different plastics and the formation techniques or different forms of packages can be formed, how they can be formed and what are the methods used for forming of different plastic forms. The first plastics were delivered in 20th century from natural raw materials like coal, oil and natural gas. Polyethylene, most widely used plastic today, was invented in 1933. It was used in packaging from the late 1940s in the form of bottles, crate, replacing wooden boxes, and film and extrusion coatings on paperboard for milk cartons. Plastic films can be joined with other plastics by co-extrusion, blending, lamination, and coating to get properties which are components could not provide alone. Plastics can be colored, printed, decorated, or labeled in several ways, depending on the type of packaging concerned. Alternatively, some plastics are glass clear, others have various levels of transparency, and their surfaces can be glossy or have matte finish. Plastics are also used to store and distribute food in bulk in form of drums, intermediate bulk containers, crates, fresh produce trays, and plastic sacks, and are also used for returnable pallets as an alternative to wood. The plastic raw material, also known as resin, is usually supplied by the polymer manufacturer in the form of pellets. Some plastics in powder form are used in certain processes, while some plastics are used to make coatings, adhesives, or additives in other packaging related processes. The first step in the conversion of plastic resin into film, sheets, containers, etc. is to change the pellets from solids to liquid or molten phase in an extruder. The plastic is melted by combining of high pressure, friction and externally applied heat. This is done by forcing the pellets along the barrel of an extruder using specially designed screw under controlled conditions that ensure that production of a homogeneous melt prior to extrusion. For the manufacture of film, the molten plastic is forced through a narrow slot or a die. For the manufacture of packaging such as bottles and closures, the molten plastic is forced into shape using a precisely machined mold. In this slide, we will learn about different plastic films. The films are normally having thickness below 100 microns and they are used for packaging of different food material as overwrap or can be formed into sachets or bags, etc. While the plastic sheets are having thickness up to 200 microns and they can be converted into different pots, cups, tubs, etc. The properties of film or the sheet depends on the type of plastic material used as well as the different laminations has been carried out. Film and sheet extrusion. Extrusion is of the important plastic processing methods used today. Most plastic materials are processed in extruders and commonly pass through two or more extruders on their way from chemical reactor to the finished product. All of the thermoplastics are formed into sheet or film by process of screw extrusion. The heat of extruder is the screw which rotates within close fitting and heated barrel. It is capable of pumping a material under specific operating conditions at a specific rate, depending on the resistance at the delivery and against which the extruder is required to pump. The extruder resembles a mincer into which granules are fed, heated and compressed until they fuse into melt, which is forced through a slot or circular die. Sufficient heat is produced by the energy of the screw to allow the process to continue with very little heat input. There are basically two processes by which the extruded thermoplastic can be converted into film: the tubular process and the flat film process. The tubular process. In this process, a thin tube is extruded and by blowing air through the die head, the tube is inflated into a thin bubble, which is cooled, flattened out and wound up. The ratio of bubble diameter to die diameter is known as blow-up ratio. Most low-density polyethylene blown films used in packaging are made using blow-up ratios of 2 to 2.5:1. Blown film extrusion can produce defects such as variations in film thickness, surface defects, low tensile and impact strength, haze, blocking and wrinkling. The properties of the film depend strongly on the polymer used and processing conditions. The higher the density, the lower the flexibility and greater the brittleness. The higher the molecular weight, the greater the tensile strength and resistance to film brittleness at low temperatures, but the lower the transparency. Another method is a flat film process. It is also known as cast film or slit die extrusion. The molten polymer is extruded through a slit die into a quenching bath or onto a chilled roller. In both cases, rapid cooling of the extruded film is most important. The ratio of Holoff rate to the natural extrusion rate is referred to as the drawdown ratio. Drawdown ratios between 20:1 to 40:1 are generally typical. The advantages of flat film processes include less thickness variation, very high outputs and superior optical properties. This latter advantage is consequence of the quicker cooling which can be achieved in the flat film process where cooling is by conduction compared with the tubular film process where cooling is done by convection. Next process is co-extrusion. It is possible to co-extrude simultaneously two or more polymers which fuse at the point of film formation into a single web by using combination adapters. Such process is known as co-extrusion and permits the production of single web having properties not possessed by any one of the component polymers. A two-component slot die is capable of producing a 2 or 3 layer film from two materials, while a 3-component die can produce a 5-layer film from 3 materials. Next method is solution casting. It can be used where the best surface properties are desired in plastic film or sheet. The plastic granules or powder with any desired plasticizer, colorant, etc. are dissolved in a suitable solvent. After filtering, the solution is cast from a slot die onto a moving, highly polished stainless steel belt. The solvent is removed by controlled heating and solvent-free, sparkling, clear, flat film is taken off from take-off section of the casting belt. Some cellulose acetate, butyrate and propionate films are produced by solution casting as well as ethyl cellulose films. Other materials which can or have been made into film or sheet by this technique are PVC, vinyl chloride, vinyl acetate, copolymers, polycarbonate and PVA. Orientation of thermoplastic film is a process of stretching the material in such a manner as to line up the molecular chains in a predetermined direction. Once lined up, the ordered arrangement is frozen in the strained condition. Biaxially oriented film possesses higher tensile and impact strength, improved flexibility, clarity, stiffness and toughness, and increased shrinkability. Gas and water vapor permeability may also be reduced, generally by 10 to 50% depending on the type of polymer and the degree and temperature of orientation. The most common method used to orient a thermoplastic film is to stretch it after it has been heated to temperature at which it is soft. This temperature is below the flow temperature at which the molecules would glide readily past one another when the material is stressed, but above the glass transition temperature. As a result of this stretching, the direction of the molecules changes towards that in which the material is stressed and the molecules are extended like springs. The temperature is then dropped below the softening point of the material while the molecules are held in this configuration, so that the molecules are frozen in the strained position, which improves the properties. Next method is lamination. Although lamination is the process of bringing two or more webs together and bonding them with an adhesive or by heating, a laminate is defined as any combination of distinctly different plastic film materials or plastic plus non-plastic materials like paper, aluminum foil and regenerated cellulose, where each major web is generally thicker than 6 microns, regardless of the method of manufacture. There is no upper limit to the possible number of webs, but 2 is the obvious minimum and one of this must be thermoplastic. There are two main techniques employed in the fabrication of laminates: adhesive lamination and extrusion coating. The associated techniques of coating without extrusion is an important process for modifying film properties as well as a means of applying the adhesive in the adhesive lamination. There are two types of coating processes. In one, an excess coating is applied to the web and the surplus is removed. In the second, a predetermined amount is applied to the web using rollers or other equipment. Nitrocellulose and vinyl chloride copolymers are common surface coatings used, but synthetic resins, acrylics and many other formulations are also used for varnishing, barrier formation and heat sealing. A recent trend is towards the use of cold seal coatings which are based on latex. They require only contact pressure for two coated surfaces to adhere and permit packaging machine speeds to be considerably increased. In addition, damage to the heat sensitive foods such as chocolate coated confectionery is avoided. Blow molding is a process to produce hollow objects and was practiced with glass in ancient times, and the basic technique have been derived from those developed by the glass industry. Today, a wide range of blow molded bottles and containers is produced for use in food packaging. In blow molding, a molten tube of thermoplastic known as perizon is surrounded by a cooled mold having the desired shape. A gas is introduced into the tube, causing the molten mass to increase against the wall of mold where it solidifies on cooling. The mold is then opened and the bottle is ejected. Normally, the process consists of three stages: melting the resin, forming the perizon and blowing the perizon to produce the final shape. The blowing step may take from a few seconds to more than a minute for large shapes. The rate limiting step is cooling of the molded shapes. There are two techniques for plasticizing resin and forming perizon: extrusion, which produces a continuous perizon that has to be cut into required length. This is the most common method used. Another one is injection molding, where the perizon is formed in one mold and then transferred into another mold for blowing. Extrusion blow molding. In the simplest method of extrusion blow molding, a mold is mounted under the die and the perizon extruded between the open halves of the mold. When the perizon reaches the proper length, the extruder is stopped and the mold closes around the perizon. A blow pin fixed inside the die head allows air to enter the perizon into final shape. The shape of bottle or jar is defined, but the distribution of material and wall thickness is less well controlled. The cycle restarts after the part has cooled and the mold opened. Extrusion blow molding is widely used with HDPE, PP, PVC and acrylonitrile copolymers. The common grades of PET cannot be extrusion blown. A development in the production of co-extruded bottles where two or more extruders, each handling a different plastic material, produce a multi-layer perizon having the desired properties. For example, a high barrier, high cost material might be sandwiched between layers of relatively low cost material to give a bottle with the desired barrier properties as an economical price. Another method is injection blow molding. It is a non-continuous cyclic process and most closely bear a resemblance to blowing of glass bottles. The perizon is formed in one mold and then, while still molten, is transferred to a second mold where blowing with compressed air forms the final shape. The mold is opened and the bottle is ejected after cooling. Several molds must be needed if the injection molding machine is to operate near full capacity. The major advantage of injection blow molding over extrusion blow molding is that the process is virtually scrap free. The finished part usually requiring no further trimming, reaming or other finishing steps. In addition, the dimensions of bottle show very slight variation from bottle to bottle, and with some materials improved strength and clarity are attained due to the effect of limited degree of biaxial orientation. The resins most commonly used for injection blow molding are HDPE, PP, PS and PVC. Recently, PET has been injection blow molded and is likely to replace PVC in some applications. Stretch blow molding or biaxial blow molding is a process where bottles with appreciable orientation in both longitudinal and transverse direction are produced. To produce a biaxially molded bottle, a perizon is stretched longitudinally under heat and blown into bottle with consequent transverse orientation. Stretch blow molding is particularly important in the field of carbonated beverage packaging using PET bottles, but is limited to relatively simple bottle shapes. For best results, the resin molecules must be conditioned, stretched and oriented at just above the glass transition temperature, where the resin can be moved without risk of crystallization. The reheat blow molding method using two stages is the most widely used of the various stretch blow molding methods. First, the perizon are injection molded in a completely separate stage and stored at ambient temperature until required. They are reheated to 90 to 110 degrees centigrade and then blown to their final shape. No stretch color at the top and bottom of the bottle. Typical stretch ratios for 2 liter PET bottle are 2.3:1 in the axial direction and 3.9:1 in the hoop transverse direction. PET is the major stretch blown resin, but PVC, PP, acrylonitrile resins are also stretch blow molded. Next is injection molding. This process is consists of softening material in a heated cylinder and injecting it under high pressure into a relatively cold mold where solidification takes place. It is major method for converting thermoplastics and is widely used for producing tubs and jars used for packaging yogurt and margarine, as well as various caps, spouts and dispensers. It is also used to produce retortable plastic containers from polypropylene. The injection molding process occurs in three consecutive steps. First one, feeding the thermally plasticizing granules by means of an extrusion type screw that rotates until the required amount of melt has been conveyed to the front of the barrel. Second, injecting a calculated amount of stock into cold cavity. And third, cooling and ejecting the molded components. High production rates are possible, and because injection molds are expensive, short production runs are uneconomic. Resins, which are generally injection molded, include low and high density polyethylene, PP, PET, and the latter are preform for stretch blown beverage bottles. Compression molding. This is one of the oldest method of molding thermoset resins, that is plastics that in their formed or cured state are infusible and insoluble owing to cross linking. It has been used for many years in food packaging for the production of screw caps from urea formaldehyde for bottles and jars. Compression molding, a preset amount of resin is placed in the lower half of a heated mold. The top of the mold is then brought down into the matching bottom cavity and heat and pressure are applied, causing the plastic to melt and flow until it fills the mold. After setting, the mold is opened and the molding is ejected. There has been a revival of interest in thermoset resins and compression molding because of the demand for ovenable packages, like for frozen meals that can go from the freezer directly to an oven and then to the table. Thermoforming. In this process, a sheet of generally 75 to 200 mm thick is heated to its softening temperature, commonly by means of an infrared radiant panel heater. By some pneumatic or mechanical means, the sheet is forced against a mold shape, and after cooling the part is removed and trimmed. Typical thermoplastics used for thermoforming includes PS, PVC, cellulose acetate and polyamides. There are three main techniques for thermoforming. First is vacuum forming, in which the sheet is placed over a mold and heated from above until soft. A vacuum is created between the sheet and the mold, and atmospheric pressure above the sheet forces it onto the mold where it is cooled sufficiently to retain its shape. Second one, pressure forming, which is identical to vacuum forming except that the positive pressure is applied to the sheet from top, which forces the softened sheet into the mold. The pressure differential able to be obtained by this method can far exceed that obtained using vacuum forming. Third one is matched mold forming, where heated sheet is pressed into shape by trapping it between matched male and female molds. The first two techniques results in thinning of the sheet and substantial reduction in barrier properties in inverse proportion to the square of increase in area. The deeper the draw, the less uniform the wall thickness and barrier properties. Thermally stable PET containers are common for dual ovenable applications for chilled, frozen and retortable foods. Self-stable applications where the food can be reheated in the package using either a microwave or conventional oven. These containers are known as crystallized PET or CPET and are able at temperatures up to 230 degrees centigrade. Amorphous PET begins to soften at temperatures over 63 degrees centigrade. The CPET process is based on orthodox reheat thermoforming, in which an extruded PET sheet containing an added nucleant material is reheated to around 170 degrees centigrade, where it softens. It is then thermoformed into hot mold and held for a crystalline structure to develop for long period. It is then transferred into second mold, where it is formed. Plastic have been used widely since 1940s due largely to their desirable properties, which include a high strength to weight ratio, good insulating and cushioning properties. A wide range of plastic polymers can be formed, comprising low and high density polyethylene, PP, ethylene copolymers, cellulose acetate, PS and polyurethane. The market is dominated by last two polymers, with PS being used in preference to PU for food contact applications. Cell formation is initiated by foaming agents. Physical foaming agents are compounds that change their physical state during cell growth, and most important are volatile liquids with boiling points below 110 degrees centigrade at atmosphere. Chemical foaming agents decomposed under heat at least one gaseous decomposition product. Usually it is nitrogen. PS foams can be formed by two processes, injection molding and extrusion. For injection molded foam, machines resembling normal injection molding machines are used, except that steam is injected to heat the foaming agent containing beads. Extruded PS foam is produced by free expansion of hot PS blowing agents and additives through the slit orifice of a high L by D ratio extruder to about 40 times the pre-extrusion volume. The amount and the type of blowing agent control the density of the foam produced. So, to concluding, we can say that there are various methods for conversion and formation of thermoplastic packaging materials like extrusion, lamination or coating, blow molding, injection molding, orientation, thermoforming, etc. Each method has its typical characteristics, advantages and disadvantages. Research focuses is now on newer methods of thermoplastic conversion, which are fast and efficient and also includes recycled feedstock generated as waste during formation of various shapes. So friends, in this module we have learned about different methods of forming different shapes of plastic materials, which includes thermoforming, injection molding, blow molding, injection blow molding, extrusion, etc. So still some research needs to be developed for the development of newer techniques which are giving faster results, and then which also includes the wastage or reduce the wastage, then only we will have the better plastics with better economies. Thank you.